Normally, when we think about changes in state, we think about changes in state at what's considered a constant pressure. So at the same room pressure here, same atmospheric pressure that we have in our room. But you can also change states by changing the pressure, but keeping it at a constant temperature. So we're going to look at what a change in state or a phase change graph looks like when we're looking at both pressure and temperature. So on our x-axis, we have our temperature increasing as you move across, and on our y-axis, we have pressure. It's increasing as you move up. Each of these curved lines is a point at which the two phases exist in equilibrium. So it means they both exist at the same time. So along this line here, up until you get to what's called the triple point, both solid and gas exist at the same time. Along this line is both solid and liquid, and this line is both liquid and gas. So it's the line between those two phases. Solids will always be on this side of the graph, liquids will always be up here, and gases will always be down at the bottom along the temperature axis. To look at where a phase change might happen, you have to look at what's going on along that line. So say, for instance, we wanted to keep something at a constant temperature, but we wanted to change from a liquid to a gas. So constant temperature means we'd be going up, which means we'd have to increase pressure. If you wanted to, so that would be gas to a liquid, so that would be condensing. If we wanted it to evaporate at a constant temperature, we'd have to decrease pressure. Go from a liquid to a gas. Likewise, if we wanted to go from a liquid to a solid at a constant pressure, or at a constant temperature, we would have to, so liquid to solid, we'd have to increase pressure, so that would be freezing. And if we wanted to melt something at a constant temperature, we'd have to decrease our pressure. So that's our melting. So just by changing the pressure, you can make changes in state happen. You don't have to just change the temperature. If you wanted to change the temperature, though, you'd be looking at constant pressures. So you'd be going horizontally like this across those lines. And those are the points. So at this point, we would read where it intersects that line. We drop all the way down, and that would be our temperature. And then we'd look over here, and that would be our pressure. And at that temperature and that pressure, you would melt. You'd go from a solid to a liquid. A couple other points about this graph. We have the triple point here in the middle. That's the point at which both solid, liquid, and gas, all three of the states exist at the same time. So it's at that particular temperature, so that temperature there, and that particular pressure. At that pressure and that temperature, all three states exist at the same time. The critical point is the point beyond which the temperature is so high, it doesn't matter how much pressure you apply, it doesn't matter if you keep increasing pressure, you're not going to make the gas go from a gas to a liquid. That is considered a supercritical fluid. That's not necessarily a term you need to know, but that's a state of matter beyond here that pressure does not have an effect on. So that's that shaded area up there beyond the critical point. So we're going to do a little bit of practice on how to read one of these graphs, just so that we get used to what types of information we can get out of it.